So our next speaker is Charles Bergan from Qualcomm. Charles has gotten his degrees, all of his degrees from UCSD, and then joined Qualcomm, where he's now vice president in charge of software design. He's the head of the software group in the research part of Qualcomm. He has worked on all of the radio technologies at Qualcomm, from CDMA up to LTE. And in addition to all of that, he is also in charge of the contact with UCSD. And he told me that at some point he came to UCSD to discuss things with students, and a student came and asked him what Qualcomm does. So I didn't want to mention that. So he decided to give us a talk to let us know that they work on radios and a lot more. And just in case you're also preparing this kind of a question for Charles at the end, I should give you a little bit of advice that he's been practicing martial arts for 28 years, and in fact even teaches karate at UCSD. So just be a little aware of that. So Charles.
Hi, it's great to be here. So this is actually a presentation that usually takes more than 28 minutes, so excuse me if I go a little bit quick. You probably are expecting to see a bunch of radio stuff here, and there's going to be a lot of radio stuff, but I'm going to try to focus on the whole lot more stuff too. As I like to say, we're a highly overeducated group of researchers, lots of PhDs and master's students. We do basically every kind of engineering there is, from systems, hardware, software. We have test engineering. This is actually a radio array. One of the things that people probably don't know is that the research division actually runs a huge radio network in San Diego. We have about 15 or 20 different base stations that are up at any one time. This is one of the buildings up here at Morehouse. Probably actually covers this area. And that's a radio array, an array of antennas that you can see up there, and the group that works on it. So I'm not going to read the slides, but I'll describe them. We actually have 10 research groups around the world. I'm actually personally responsible for the Silicon Valley group here and the Cambridge, England group, but there's groups all over the world. Mostly each group has a specialty. For instance, these guys do software, and we'll talk about that a little bit. These guys are the guys who design the crate processors, that are the ARM processors that go on all of our chips. And for instance, those guys are currently working on 2.5 gig quad-core chips, and forward-looking, they're going to be in 16 nanometer FinFETs before too long, and really exciting amount of CPU power that's coming. So as Alon mentioned, I'm actually the point of contact for UCSD and the University Relations Program, as well as the head of the software department. And we actually have, I think we're up to 35 US universities now that we go and visit. There are over 65 guys who fan out about this time of the year to go both try and recruit new graduate students and also try and connect with all the professors. And one of the things I'd certainly invite all the professors and grad students here to do is reach out to me and use that point of contact to try to either get research grants. We have money, I think $22 billion in the bank and counting. So certainly come talk to us. We do have some money, and we have some smart guys and lots of interesting ways to interact. Again, I'm going to have to kind of go fast because it's a long presentation and I want to keep going. But if you have a question, just yell out and I'll stop. Certainly most people are used to thinking about Qualcomm in the 3G and 4G. We're actually doing a lot of things with Wi-Fi. We bought Atheros. It's a purchase 2 years ago that got us into Wi-Fi, so we're the second biggest provider of Wi-Fi. We actually do a lot of things now on the software side as well. If you look at a current phone, most of the time people are not buying it for the radio. Case in point, look at the older iPhones, actually not very good radios, especially the pre-Qualcomm iPhones. And that was okay because the user experience made up for it. And so one of the things we've been trying to do is work on the user experience side, and what can we do to enhance that on Qualcomm-based chips or Qualcomm-based devices. So we'll talk about the stuff you guys know really well. I'll probably skip over this pretty quickly. But we really do research on all the WAN standards. For 1x advanced, DO, HSPA plus, that's UMTS, LTE advanced, which is het nets, interference cancellation, and TDS-CDMA, which is the Chinese standard for 3G. Other things we're doing to actually improve WAN beyond sort of the classical techniques. Ultrason, which is self-organizing networks. We're going to talk more about that later. But basically, it's put a small base station in every room. Our preference would be every power outlet gets a little base station doing 3G and 4G. And using power line communications as backhaul and suck all the capacity off the macro network. Right? Macro network is very impacted right now. You can't create more spectrum very easily. So it's actually better if we can put little tiny base stations that are doing 3G and 4G in every room. One of the nice things about it then is that you lose all of the what is your Wi-Fi key, and it's a managed network, right? And so basically, just like your phone, when's the last time you had to type your authentication credentials into your phone? They're actually much tighter than they are on Wi-Fi, but roaming works, everything works. And you could do that actually at the room level as well. And that's one of the things that these guys are working on. And I'll talk about that a little bit. The research division, mostly because the mobile chip division was too busy, but the research division did the base station chips. So we actually built the base station modem chips, the CSMs and the FSMs. And we, as part of that, work on traffic management. So how do you bond channels together? And we actually do a broadcast network design for LTE that we'll talk about. We do Wi-Fi. Some people are surprised at that, but we're actually a major contributor to 11AC and 11AD, which is the 5 gig and 60 gig designs in Wi-Fi, and 11AH, which is a very low power network, designed basically to try and wipe out ZigBee and all the evildoers out there in 15.4. Obviously, I'm just joking. They're not evildoers, but I think we have too many radio standards to some degree in the house. It makes it very hard for an individual user or a home user to actually debug things. And 11AH, the nice thing is you'll actually have one base station that then can talk to all your devices, from the moisture sensor in your lawn that's on a single AA and runs for a couple of years, up to your TVs that are doing 11AD over 10 meters to get HDMI. LT Direct, sometimes you want to just send something locally or discover stuff that's local to you, and LT Direct talks about that. We'll do a little bit more on that. And we actually do indoor navigation as well, which is round-trip time-based indoor navigation to Wi-Fi using existing Wi-Fi base stations. And actually, there's a test program at UCSD where we're working on that. We'll talk about these later, so in the interest of time, I'm going to move on. Apologize for having to go a little bit fast, but let's just move on. So we're doing lots of things to increase the voice capacity, mostly towards pushing voice into a single channel or reducing the number of channels that we're using. And the reason there is we need those channels back for data. Voice is less than 1% of the network load right now, but it takes up more than 1% of the capacity because of the fixed channels. So if we can keep pushing things down into fewer channels, things go better. So we're using quasi-orthogonal coding, interference cancellation, narrow vocoders, all trying to press more and more voice into fewer and fewer channels. And it's actually been very effective. Like it says here, we get about 4 times increase in voice capacity. DO is doing channel bonding, all sort of classical techniques. These things are being trialed and they're underway. Interference cancellation, smart networks, so trying to decide which base station you should connect with. The best base station is not always the one closest to you or the strongest signal, because maybe that was the impacted one. Maybe we actually want to tell you to go to a base station that's far away that you can barely reach, but is lightly loaded. This is the graph for HSPA. And one of the things I like to point out is the brand new iPhones are over here, and this is where my phone is in the lab, is over here. Right? It's a big difference. This is a quad channel USBA or HSPA modem. That's how you get up to the 336, 64 QAM, and MIMO. And this will probably be a shipping part for laptops. But right now, it's a big rack of FPGAs sitting in my lab. LTE is going to get better and better and more important. Like we talked about, plug-and-play relays, picos, femtos, remote radio heads, all techniques you guys probably know. But this stuff is coming in spades for LTE because we need to scoop up every little last bit of spectrum and make the most use of it. And a big part of that is reducing the base station footprint. We actually, like I said, we've run a test bed. This is actually our San Diego test bed. So UCSD is over here someplace. This is I-5. And you can see we've got the various base stations here. And this is one of our vans. So if you see this driving around, this is what it looks like on the inside. I like to point out the really cool stereo equipment that they had mounted in the wall. So at 2 a.m. they could blast the appropriate tunes necessary to keep them awake. But you can see there's actually running drive test data right here. I'm going to skip this slide. Actually, I'm going to skip that slide. So this is really the idea for open access neighborhood small cells. Basically, Verizon ships you a box, says, please plug this into your wall, plug the Ethernet jack in, and just let it sit there. And if you do that, we'll reduce your rates by X%. And what they end up doing then is getting coverage in a whole neighborhood without having to put any new macro cells in. Because all these things are open access, meaning that anybody on the Verizon network could actually get to that cell as they're walking around, driving around. It plug and play, it just works. If it breaks, they get a new box in the mail. It says, hey, you know that other one? Just take that, throw that one in the trash, and put a new one in, plug that one into the wall. Thanks very much. If you look at here's a little, we'll see if this works here. Hopefully it will.
We have deployed 7 indoor femtocells inside multiple buildings. These femtocells are located inside the building, generally away from windows. The femtocells transmit at 10 milliwatt and provide good coverage outside of the buildings. This video shows actual data logged during outdoor drive tests. Multiple handovers occur between femtocells while maintaining good voice quality and data throughput.
So you can see, actually, one thing I like to notice is, the best base station may be behind you, right? You think, oh, if it's going away, even though there's a base station that was close, because of multipath problems, the best base station was actually directly behind him. And these are, on 10 dBm networks, as I mentioned, very low power, easy to, basically put anywhere, and they're pretty impressive. And one of the most impressive things is this is how big the circuit board is for that network. So this is actually the femto evaluation platform card. Next to a deck of cards, and this is the Ethernet connector that it goes in, and you can see the RF connectors there. This has got, I think, two gigahertz crate processors on board. One does the radio stack, the other one is free for use. And it's really pretty impressive. The cost of this is less than $100. If you think of a cell phone, you rip off the display, you rip off the keyboard, all the different stuff, battery, you actually can see why it costs so much less than a cell phone and why you could really deploy it anywhere. And I think it's really exciting because the improvement in capacity of the network is really going to depend on very small cell, like 10-meter kind of radius cells. That's how we're going to get to 1,000x, right? Which is really where we need to be. We need to be about 1,000 times more capacity than we have today. If you look at the graphs, 5 years from now, it's 1,000 times more if you let it go. I'll skip the base station modems and traffic management. Here's something that's kind of interesting. I'm trying to get to the non-radio stuff. I know my time is very limited here. One of the things that you can actually do with an LTE network is do a broadcast network. And so many companies are interested in things like, what if can we send out the NFL, Monday Night Football over LTE? And what would it take? You have to synchronize the whole network and broadcast across it. You can actually get better utilization of a frequency than if you're using a broadcast TV, actually by quite a bit. And the nice thing is you only need to turn it on during Monday Night Football, right? Every other time it's carrying normal traffic. Probably familiar with WLAN stuff, so I'll try and move on. But I think it's really interesting stuff. At 60 gigahertz, we can get over 10 gigabits a second over about 10 meters. That lets you do uncompressed HDMI, which is very nice. It means you can just stack up your stereo equipment, and they all talk to each other. One of the problems, of course, is you stack up your stereo equipment and the guy on the other side of your apartment wall can also get your movies. So we have to work on the security side and trying to make it easy to set up. We talked about 11AH and sensors, Internet of Everything, TV white space offloading. It goes on and on and on. It's really a pretty exciting area to think about. Let's just get to the fun stuff. Indoor navigation. This is kind of interesting. Finding good use cases for this, I think, is a challenge. But the one that always comes up is find your way at a subway station or at an airport. Certainly, guys like Best Buy, Walmart, they're really interested because there's some surveys that say about 20% of the customers actually can't find what they're looking for in the store, and they try to capture that with the did you find everything you were looking for on your way out? And of course, by then you're so frustrated, you go, yes, I did. And that's the end of it, right? And of course, they know you probably didn't because you probably wouldn't have that answer in that tone, but they've lost the sale. So here, if you had a little app or some way to say, okay, Charles, USB cables are actually 2 aisles over, not where you are, that might allow them to capture that 20%, which is a big number. I mean, these are huge, huge numbers. So this is actually what I was trying to get to, if you couldn't tell. Augmented reality came up in Sanjay's presentation. It's really become huge. You have over 30,000 developers using augmented reality. So in augmented reality, the camera on the back of the phone detects a target and then applies some augmentation to it so you can see something in front of it, which is typically some kind of commercial or added information. One of my favorite ones is the Cisco IP phones that sit on our desk. We have an app for it that actually explains which buttons you have to press to actually transfer or conference in another call. Right? Because of course you can never remember that because you do it like twice a year. When you actually get there and you're looking at the soft keys and you can't remember what to do. Well, here it actually, since it's augmented reality, it actually locks the squares saying press this button to the button from the view you have. So it's not just a picture of the phone, press this button. It's actually your phone through the camera with a little arrow pointing at the button you have to press. And it actually looks for your finger to obscure the button. So when you press the button, it says, okay, good, now press this other button, right? Which is kind of fun. But lots of advertising, cars that pop out of magazines and other things. I think text recognition is actually one of the areas that we've been working on lately that is pretty exciting. And here what you're trying to do is, and you think, okay, OCR has been done, all right, except that's not what we're really doing, not Latin characters anyways. What we're really trying to do is drawn fonts. So kanji, Korean, Chinese. And so here's an app that the guys in Korea are working on. And the problem with drawn, so you can see the red on there and the square, and it's when it locks into the font, and then it actually looks up the translation. So the problem with these drawn fonts is that each font that's used is slightly different from the others. These are artistic fonts. And so you can't use many of the standard OCR techniques. There's a whole new set of OCR techniques you have to use, many of them invented by these guys. And the way they actually get the translations is scraping Google Images and Wikipedia and things like that. So they actually go through looking for those characters, scrape the characters up and the translations given in the text, and use those to generate the database. Another thing we're working on is sound recognition. So there, what you're trying to do is figure out the context you're in from sound. My prime example for that is you'd probably like your phone to operate differently depending on whether you're in your car or not. So if you're in your car, you might actually want the display to have some big buttons that say, call your wife, call your boss, call your kids, rather than contact database search, QWERTY keyboard, right? It's death by distraction. You're never going to be able to type that thing while you're driving. So, but how do you figure out if you're in a car? Well, people immediately say accelerometers, right? We can easily figure out you're traveling 40 miles an hour, there's no chance it's anything but a car. Except public transportation is the problem, right? And so then you start thinking, well, what about a bus? Okay, but if the bus is behind the car, the acceleration profile, or the car is behind the bus, the acceleration profile is the same. So it's very hard to differentiate a bus from a car, from a subway. But if I put any of you, blindfolded you, and put you in a vehicle, and then started up the vehicle, you'd 100% know what you were in, right? In fact, probably by just the door sound, you'd figure out what you were in, right? Because you hear the whoomph and you go, okay, that's a car. Or you hear the of this pneumatic thing, you'd be like, okay, it's a bus or a subway or something like that, right? So what can you do with that? More Korean, more guys.
We are going to introduce sound recognition in this project.
Hold on a second. Oh, wait a minute. That was not right.
It makes your cell phone understand your ambient sound.
So what I want to, so this is the Korean research group. So this is the speaker that's going to play the sounds, and you'll notice on the display, actually, it says what the current analysis says it is. And so what they've done here is actually, it's machine learning, and they feed a whole bunch of samples to it. And none of the samples are playing, by the way, were in the training set. So they actually have to, do it for real. And the interesting part is it's not actually looking, it's not actually looking for particular things that we would think about when we're looking for speech, right? So it actually had the machine learning learn how to classify speech against other things. And then they play a bunch of different sounds to it to show what it could hear.
First, let's take a bus.
So this is where you're trying to look, hopefully.
Now we need to transfer to subway.
Let me try to call this number.
Again, not trained on this crying, trained on crying in general.
Is your baby crying?
No, it's not. Let's listen to the music.
Again, not trained on this song.
Thank you for watching Listen Demo video. Did you like it?
And so the key there is trying to figure out the context you're in. Because if you can figure out the context you're in, you can figure out what the phone should do that's better, right? If your baby is crying, you might actually want to change the enunciators and the way the enunciators work, right? It's not probably the best time for your mother-in-law's call to ring your phone, right? You probably are like, that one can wait, right? In fact, probably most of the phone can wait, right? And the only really way to figure that out is to hear what's going on. And so one of the things we've been working on is in the always-on field is can we run audio signal detectors all the time? So can we push the power down on custom hardware with sufficient privacy concerns, so actually sampling the data such that even if you had the sampled data outside the phone, you could actually reconstruct intelligible speech, but figure out what's going on around you just by listening, which turns out to be a very low-power sensor that we can use to try to generate an interesting context and then change the behavior of the phone. You can imagine for each of those things, you actually might want different behaviors for the phone, and maybe even tell your colleagues or your family what's going on. For instance, if you're trying to meet at the museum and they know I'm on a subway, well, I probably can't get GPS data, but by saying I'm on a subway, you could guess that I'm actually trying to get to the park versus some other set of things. And then there's the privacy concerns, right? If one of my good examples is near my house, there's an Apple store near a supermarket, right? And so for sharing location data, I might not always want to share exactly where I am because sometimes instead of the supermarket, I'm actually at the Apple store. And similarly, if I'm supposed to be on the subway but I'm not, do I really want to share that? Well, hopefully I have a good relationship, and I'm happy to share that and explain myself later. But there are some issues around how would you share that data and try to make it useful? Because if I'm actually just running late, and I think many of us probably are in this category, just sending a message to the meeting participants saying, "Hey, Charles is only a couple minutes late. I know that he just went by. I just saw this Wi-Fi SSID, and I know it's just outside Atkinson Hall, and he's currently moving at 3 miles an hour, and he'll be. I can compute that he's going to actually be there in 5 minutes. That would be great, right? Now, But if I was actually not doing that or going the opposite way, do I really want him to send a message saying, Charles is just, going the wrong way. He's, drinking with Tom. He's off doing some goofy thing. I don't know what's going on. But there's no chance he's actually going to make his talk, right? So I think there's some interesting concerns there. But the power part, trying to get super low power processors, super low power microphone activity detectors, cut the leakage out, it's really an interesting work. In the end, you actually want your phone to sort of sense everything around you, be a control panel for everything. I'd like to be able to control the lights here, change the slides, control my house all from my phone, and that all is going to happen. We do HTTP delivery, so trying to pick good video rates is important. Heard about that earlier. Actually, we're working with them, and so it really Qualcomm Research tries to create. Look at all the things that people do and see how can we improve them. So some of this work here is with the digital fountain guys, is using fountain codes and forward error correction to try and improve the quality of the video without actually impacting the delivery bandwidth. As you might imagine, we do a lot of stuff on processors, devices. We have a whole antenna group. Most of our customers use reference antenna design from us. We have all kinds of interesting pre-distortion, post-distortion, envelope tracking, all kinds of really cool stuff that goes underneath the covers of a phone. We actually do concurrency research. So one of the things as we're adding more and more processors to a phone, basically they sit idling and leaking. So we got to figure out what to do with them. Part of the problem is if you're a software developer, you're going to develop for the lowest common denominator platform. For right now, it's a single core like iPhone, 1. So if you develop for that, and then I feed you a 2.5 gig quad-core processor, you're just going to sit there. So how can we actually, auto-parallelize, auto-vectorize, have discovered parallelism, be able to express programs in a way so that we can take the parallelism and run it on any kind of heterogeneous processor arrangement. It's really interesting work that we're doing up in Silicon Valley. The other interesting thing is, so the app comes in Dalvik code, at least on Android, and that's not necessarily the most efficient thing to run. And what if we translate it on the fly? Well, right now it's translated to an ARM CPU. What if we actually translate it instead to a DSP or a GPU, or maybe all of the above, and then decided which call to make at any one point in time? And that's what the Griffin project's working on. I think I am just out of time, but if we have time for questions, I'll be happy to take questions. Sir?
I'm curious about the TV white space offloading. Is that
Sure.
Because of the antennas and the frequencies being used, are you looking at maybe some kind of picocells that translate from, say,
Right, relays, yeah, exactly.
communicate,
Yeah, that's a good question. So the question, if you can't hear it, is what about TV white space? So it's typically new frequencies. So are you going to relay to existing frequencies, or is it going to be a direct transmission? I think, sort of, as you might expect, the answer is probably going to be some of all of the above. But I think you will see a lot of relays. And I think one of the things you'll see is the phone sort of becomes the relay for a lot of other devices. Already you see people, that do Wi-Fi tethering, to their other devices. Which is not great for Qualcomm because you don't buy a bunch of 3G modems for all your tablets and all your toys. But I think that's going to be typical. So you'll probably see phones have TV white space support, and then they'll just do Wi-Fi tethering. I think that'll be the typical use model. There will be some direct communications, though. No. Yeah. Yeah. So the test boxes that we use, are very small. They're typically running asterisk to interface to PBX. You can actually do calling into a normal phone system, and it's very small. If you actually want to do soft handoff rather than hard handoff, it's more complicated. But I think for most, at least for most research projects, they're probably interested more in a data network where hard handoff is not a problem. So not much. You know, PC. Oh, absolutely. Yeah, I mean, the guys who play with these things have a PC, you know, hooked up, you know, over Ethernet to their box, and that they do phone calls to a normal PBX-based phone system. And they walk around with their cell phones and call people on their desk phones and say, hey, cool, it's working. It is similar, yeah, yeah. Sir. Right.
The app that I really want is when I come home and just say hello to my wife, get a picture of her and record what she's saying, and it will tell me, one, why she's mad at me.
Yes.
You automatically give the response back. Why, your hair looks lovely.
Yes. Yes. That would be a good research project. So if we want to do an FM, you got an FMA for that. One of the things actually people have talked about actually is trying to do stress analysis or trying to do galvanic skin response on the phone. I'm actually a little bit squishy about that because it basically becomes a lie detector because that's how they work. So yeah, exactly. Why are you so stressful about that? Why are you sweating so much while you're trying to explain why you didn't show up on time? But I think actually one of the things that's really interesting, especially for people who are disabled, is to try to give back some of the senses that we would normally have. And I say it that way because I think women would say it's, you know, there's an empathic sense that somehow men are missing that, you know, maybe the phone could give back. But I think, you know, first of all, you couldn't take your phone out of your pocket, right? So you'd have to do it with an earpiece or something else. But I think it is really interesting to actually, and some of the things that people have tried to do is like things like grimace detection, more actually around in-car usage, because it turns out that if you're about to be in an accident, you actually do make a face. And it's a really good time to shut down like the call and shut down the audio and everything else. It turns out one of the reasons why it's okay to talk to a person next to you is because they're actually watching too. And so if the car swerves into your lane, they will stop talking, right? And in fact, that helps you in some ways because you realize that they went, and you're like, what? Oh, that guy. Okay. Right? And so I think there is actually, you know, all jokes aside, a lot of interesting things around what if you could mount your phone in your car and have it watch the lanes, have it listen for guys around you, maybe not watch your wife, but notice that this guy's not driving very well and say, you should either back way off or pass this guy because he's not looking so good. I don't know if we have more time. I'll keep taking questions until they give me the hook. So.
Okay. Regarding the voice sound recognition,
yeah.
How successful has the team been in, let's say you're in an outdoor environment, wind noise, road noise, cancellation?
Yeah, it's a good question. So the question is, what about background noise cancellation, especially when you're trying to analyze for certain sound patterns? So that team actually, the founder of that team founded Softmax, which actually does background noise cancellation. It's a company that Qualcomm bought. And you've seen the Softmax, it's called Fluence now as a product from Qualcomm, but it's really incredible. It can actually, with 4 mics, they have 4 people in a car talking full blast on a script, and then in the demo video, they actually switch from person to person, and basically the other people are background noise. They also have a demo where they have a boombox playing speed metal full blast with English lyrics, and a guy with a phone, and he gets up next to the boombox, and he's talking on the phone, and you can hear what the overall thing sounds like, right? Which is you can't hear anything, you just hear the song, as you might imagine, right? And then they hear what the guy on the other end of the phone hears, and it's like a low rumble in the background, because that's the uncanceled energy and the conversation. So we have some pretty incredible techniques, actually, to get the noise out. A little bit expensive CPU-wise, so you don't tend not to see them in low-end phones. But it's coming. The CPU power is coming.
Okay, let's thank Charles again.
Great. Thanks very much.